The unit circle radius degrees. Is 1,000 degrees. Pi over 6, pi over 4, pi over 3, pi over 2.
Amison, do your homework!
I'm learning about the unit circle!
What's the unit circle?
Well...
The unit circle is a circle with a radius of 1. We like to think of the unit circle as being on a graph where the x-axis and y-axis cross. The center of the circle is the origin. With this, we know that these points are 1, 0, 0, 1, -1, 0, and 0, -1. Each quadrant of the unit circle is generally divided into two 30-degree triangles and two 15-degree triangles, but it will be much easier to show this on a piece of paper versus a snowy trampoline. If we were going to measure this in radians, it would look like this. So the beginning is 2 pi because one unit circle is 2 pi. Then you would have pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, because it's half the circle, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and back to 0 or 2 pi. Now if we were to measure this in degrees, it would look like this. So at the beginning would be 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150, 180, half the circle, 210, 225, 240, 270, 300, 315, 330, and 360, or 0 again. So we already know these 4 points to the quadrantals, but we need these to figure out what the rest of the points on the circle are. So we're going to focus on finding points now. So if we want to find these points, we have to know this angle. So we're going to have this angle equals theta. Now, from our last paper, we know that this is 30 degrees, so this angle equals 30 degrees. Now we can use a triangle to help us find x and y because of the Pythagorean theorem, which we know is x squared plus y squared equals 1. So we drop a line down here, and that gives us a 90-degree angle. Now if we have a 30-degree angle and a 90-degree angle, we know that this must be 60 degrees, which makes this a 30, 60, 90 triangle. Now what do we know about 30, 60, 90 triangles? So we know the side opposite the 30 degrees is always 1/2. We also know that the side opposite the 60 degrees is always the square root of 3 over 2. Now, knowing this, that this line is also x, and this line is also y, we have our x and y points. Square root of 3 over 2 is x, and 1/2 is y. Now, the other thing we also know is that cosine equals x and sine equals y. So to just prove that this would work either way, if you want to find the cosine, you think of opposite over adjacent over hypotenuse. So you think, here's a 30 degrees, adjacent to that is the square root of 3 over 2, and the hypotenuse is this line right here, which is 1 because it's a radius of the unit circle, and we know all radians of the unit circle are 1. think of 1 over the square root of 3 over 2 gives you the square root of 3 over 2. So that gives us our x. Now sine we know is y, so we think of SO, which is opposite over hypotenuse. So the opposite of the 30 is 1/2, and the hypotenuse again is 1. So 1/2 divided by 1 equals 1/2. So then that proves that either way we would have gotten the square root of 3 over 1/2. So now we know how to do it with dropping a line, but there's also a simpler way, which is using your calculator, which for our benefit we're going to go over now. So we know if we want to find these points again, we know that this is theta. We also know this is 30 degrees. Therefore theta equals 30 degrees. Now if you plug into your calculator the cosine of 30 degrees, you're going to get the square root of 3 over 2. Since x equals cosine, that's our x. If you plug in sine 30 into your calculator, you will get 1/2. And since y equals sine, that's your y. So we go up to this triangle. This is now going to be 45-degree angle. Again, the cosine of 45 will give you your x, which is going to be the square root of 2 over 2. And the sine will give you your y, which turns out to also be the square root of 2 over 2. Finally, we have a 60-degree angle from here to here. I went a little bit too far there by accident. Plug in the cosine of 60, which gives you 1/2. The sine of 60, which gives you the square root of 3 over 2. Now, lucky for us, we can use these to predict, well, to find the other points on this circle in the other quadrants. So a cool thing to notice here is this pattern. So we know that this angle right here is 30 degrees away from the y-axis. Now we can see that this angle is also 30 degrees away from the y-axis. So it would make sense that they had the same coordinates, only one of them being negative. Now since we're still going up, we know it's going to be that the square root of 3 over 2 is still going to be positive, but since we're going negative in the x, we're going to have a negative 1/2. And that is actually the same for all of these points. So now you can see we're just going to keep going back down. So we're going to get the negative square root of 2 over 2, square root of 2 over 2, and then the negative square root of 3 over 2 is 1/2. So then following that pattern, we can see that this again is 30 degrees away, and so is this. Now this time, neither of the two are going to be positive, because now we're going negative on the x and negative on the y. So this point right here is going to be negative square root of 3 over 2 and negative 1/2. This point right here will be negative square root of 2 over 2 and negative square root of 2 over 2. This point will be negative 1/2 negative square root of 3 over 2. And then finally we have this quadrant, and again a 30 degree difference, which means they're going to have the same point, but look, we're back in positive land for the x's. So that now means we're going to have 1/2 over the square root, negative square root of 3 over 2. And we're going to have square root of 2 over 2, negative square root of 2 over 2. And then finally we'll have square root of 3 over 2 and negative 1/2. And we are back to the beginning, which would be 2 pi. And this is a unicircle.
And this is why I dropped math.
That's what makes you beautiful.